Okay, so good evening everyone. So this week I will discuss about determinants. Are you guys here?
Good evening, sir.
So should I start?
Yes, sir.
Okay, fine. Okay. So the topic is determinant. Okay. So from the definition, it's very unconventional what I am giving to give a definition of determinant of matrix A, that is also denoted by determinant of A, that I can write epsilon ijk A of 1i, A of 2j and A of 3k. Have you guys ever seen this? Tell me. No. Okay. So here the thing is, what is epsilon? This is called permutation symbol. Permutation symbol. Okay. So the meaning of this is, its value is +1 if I, j and k are belongs to 1, 2, 3, 2, 3, 1 and 3, 1, 2. Okay, and its value is -1 if I, j and k belongs to such that 1, 3, 2, 2, 1, 3 and 3, 2, 1, and its value is 0 if I equal to j or j equal to k or I equal to k. Okay, so suppose you have a matrix A. Suppose you have a matrix A such that its elements are like this. Okay, so now I want to determine the determinant of A. So what will I do is, I will expand this. The meaning of here ijk, which means that you have to expand for all value of I, like for I belongs to 1, 2, 3. Similarly, j belongs to 1, 2, 3 and also k belongs to 1, 2, 3. Now I will use this formula to find the determinant of A. So the determinant of A will be, now tell me, if I will replace I equal to 1, j equal to 2 and k equal to 3, then what will be the expression? Tell me. If I replace I equal to 1, j equal to 2 and k equal to 3, then what will happen? This value will be epsilon 1, 2, 3, right? And
Yes.
you can see that when ijk is such that 1, 2, 3, then the value is 1. So 1, since we have replaced I equal to 1, j equal to 2, k equal to 3, which means that what will I write? A. It's not visible clearly. So A 1, 1, A 2, 2, A 3, 3. Okay. Now if I equal to 1 but j equal to 3 and k equal to 2, then what will happen? then you can see that here the epsilon will be what? Epsilon will be 132, which means that the value will be what? -1, and expression will be a11, a32, a23. Similarly, if I equal to 2, j equal to 3, k equal to 1, similarly I will expand for I equal to 2, j equal to 1, k equal to 3. Similarly, I equal to 3, j equal to 1, k equal to 2. Similarly, I equal to 3, j equal to 2, and k equal to 1. So then what will be the expression? If I replace I equal to 2, j equal to 3, k equal to 1, then what will happen? What will happen? Tell me.
Epsilon will be 1.
Epsilon will be 1, that is +1, okay, and that will be a21, a32, a13. Similarly, if you replace I equal to 2, j equal to 1, k equal to 3, then that will be what? -1 of a21, a12, a33. Similarly, when you replace I equal to 3 or j equal to 1, k equal to 2, that will become minus of a31, a22, and a13. Similarly, when you replace this one, then that will become plus a31, a12, a32. Okay, so now, okay, one thing I want to ask, what will happen when I equal to 1, j is equal to also 1, then what will be the value? When 0. That's why I have not included those indices which are repeating. Here you can see that none of the indices are repeating. Okay, actually here we have to sum all the indices. We have to sum all these by changing the indices. But we can see that whenever indices are repeating, those values are 0. And when indices are performing like cyclicity, you can see that cyclicity is going on. But here cyclicity is not going on. That's why the value is -1. So that's why what did I do is I have just changed the indices such that indices are not repeating. And these are the possibilities where the values are non-zero. Now I will arrange this. So you can see that when I take a11 from this, then that will be a22, a33 minus a32, a23. When I take the common a12, then that will be a21, a33 minus a31, a32. When will I take the common of a31, then the value will be a12, a12, a32 minus a22, a13. Okay, so these are the values. Now I will do one more thing. I will write like this. Okay, and here I will write is it correct or not? Tell me. Is it correct or not? Yes or no? Is it correct?
Yes, sir.
Yes. Okay. So here what will I do is I will write something like this.
Sir, we have written -1 to the power I plus j. about 1
Yeah,
plus 2?
that I will discuss. That I will discuss. I have just did like here when I take the indices 1, 2, then what did I do is I just summation the indices 1 plus 2. Okay, and here you can also assume like here what will I do is 1 plus 1 into minus 1, 1 plus 3. Okay, fine.
Okay, sir.
So yeah, so what will I do is I will write A11 C11 plus A12 C12 plus A13 C13, where C11 equal to what? A22 A23 A32 A33. Similarly, C12 equal to A21 A23 A31 A33. C13 equal to A21 A22 A31 and A32. So the thing is, you can see that the determinant of A is nothing but the summation of all these three terms, where C11 is this, C12 is this, C13 is this. But the point is from where these three are coming. Now we will look at the matrices. When you look at the matrices, so that was A11 A12 A13 A21 A22 A23 A31 A32 and A33. Okay, so you can see that whenever you are taking A11, then this thing is nothing but by cancelling or by ignoring these rows and column and the taking the determinant of this, then this one is nothing but the C11. Okay, and C12 is nothing but by taking this element and by ignoring this row and this column, then these four are coming into the picture. Similarly for A13, when you take the A13 and by ignoring the rows and columns, then you are getting these four terms. So this is the concept of the determinant. So now the thing is I cannot write like this only. There are many ways. If you take the common like this, A11 C11 plus A21 C21 plus A31 C31, this is also exactly same as this. Not only this, if you write like A12 C12 plus A22 C22 plus A32 and A32, then you can see that these three, these are nothing but the exactly the rows or exactly the columns. Here you can see that I am nothing but I am doing this A11 A21 and A31, and I have just multiplied by this term, and this term is nothing but by ignoring that element's rows and columns. So there are six ways. So you can see that like this, like this, like this, like this, like this, and like this. So which means that the determinant of A is nothing but you can represent in 5 ways. Okay?
Sir, there should be 9 ways.
How 9?
From if it's 3 by 3 matrix, then for each individual term we can have.
No. I am taking consecutive rows or columns. 1, 2, 3 or 1, 2, 3. So there are 6 ways.
Only the leading elements of the.
Not leading. If you are taking either whole rows, 1 rows, 2 rows, 3 rows, or whole columns, so there are total 6 ways. Okay? So this is the concept of determinant of A. Okay? Now suppose I want to calculate determinant of matrix of this. Suppose 1 0 0 minus 1 3 1 2 2 1 0 minus 2 1 2 0 0 1. Now I want to determine what is the determinant of A. So the clever way is whether how I am choosing either whole rows or columns. So you can see that if we are taking such rows or such column such that their elements are maximum 0, so which means that we can determine the determinant very fast. So you can see that if we choose this whole column, are you able to see? So which means that we have to take only this, and this is nothing but what? A22 and A22 and C22. That's it. And what is the A22? 1. And what is C22? Just ignore these rows and column. So which means that 1 0 minus 1 1 0, sorry,
1 minus 2.
yeah, 1 minus 2 1 minus 2 1 2 0 1.
0 1.
Yeah, again you can see that again we have to determine the determinant of this. Now again I will choose this column, okay, because you can see that all elements are 0 except this. So what will I do is I will take this. So minus 2 comma what? Cofactor. I'm not saying any kind of term, I'm just saying like C22 of this. So what is the C22? Just ignore this row and columns. So that will be 1 minus 1 2 and 1. So 1 minus 2 and just multiply this 1 minus of minus 2, that will be nothing but minus 6. So that is the way to determine the determinant of A by using this. Okay, are you guys with me?
Sir,
Yeah.
if the given matrix isn't in a square matrix, then the determinant of A can be determined.
Yeah, determinant, if you want to determine the determinant, then I have not discussed it, that matrix should be a square. Okay, you cannot determine the determinant of any kind of matrix. That matrix should be square matrix. Okay.
Okay, sir.
Okay, now I will introduce what are minors and cofactors. Okay, so I'm writing if A is a square matrix M, okay, not square matrix, then determinant of Aij is called, okay, is called minors, of A if we take out some matrix. If we take out submatrix from A by removing ith rows and jth column, okay, so this is called minor. Okay, now and minus 1 raised to the power I plus j, determinant of Aij is called what? Cofactors. Okay, are you getting? Tell me. Okay, so the definition of minor is nothing but, I've just talked about that. You have to just remove ith rows and jth column, and just you have to take the determinant of that submatrix, and if you multiply by the term minus 1 raised to the power I plus j, and the determinant of this is called cofactors. Okay. Now I will determine the cofactors. Suppose take an example. 3 1 minus 4 2 5 6 1 4 8. Okay. Now I want to determine the minor m11. Then what will be the element? Tell me. What will be that element?
So which one?
M11. I want to calculate the minor M11, which means that you
5,
have
6,
to take this one and just ignore this row and this column. Whatever the sub matrix out of that whole matrix is called minor. That is nothing but 5 6 4 8, and this value is nothing but 16. Okay. Now I want to determine what is the cofactor. The cofactor is nothing but minus 1 raised to the power 1 plus 1, that is nothing but exactly equal to 16. Similarly, if I want to calculate m12, so just ignore this row and this column, so you will get 2 6 1 8, and that value is nothing but 10. And what is the cofactor? C11 minus 1 raised to the power, sorry, C12 minus 1 raised to the power 1 plus 2. Then that value will be minus 10. Okay. Similarly,
Sir,
you can
how
get
to find C11 and C12?
what?
C11 how to calculate how to come means
Oh,
how it come minus 1.
yeah. Yeah. Here, what did I do is, I told you the formula, right? So cofactor will be nothing but minus 1 raised to the power I plus j. Whatever the indices you are taking, you have to just sum that indices. Okay. So here you can see that I am taking the index 1 2, which means that 1 plus 2, that is nothing but minus times. Okay, because minus 1 raised to the power odd power is called what? Odd power is what? Minus 1. Okay, that's why minus 1 is coming to the picture.
Okay.
Is it fine?
Yes.
Yeah. Similarly, if I want to calculate C13, that value is nothing but 3. Then what is the C13? If M1 is 3, then what is C13? If M21 equal to 24, then what is the C21? If M22
C13 will be 3, M24 will be minus 24.
minus 24. Okay. M22 is what? Tell me M22. Tell me
M22 would be
M23.
plus
Tell
22.
me M31. Tell me M32. Tell me M33. What is M22? What is M22? Yeah. Okay. Similarly, the summation of these two is exactly the even number, so that's why it is 20. What is M23? 11. That will be minus 11. What is M31? 26. That will be 26 only. M32? 26. So that will be minus 26. M33? 13. 33 is what?
130.
Yeah, 13.
130.
Now I have to write minor matrix. So we have to write whatever element we got it. So that is nothing but 16, 10, 3, 24, 28, 11, 26, 26 and 13. Okay. Similarly, I want to write cofactor matrix. That is nothing but 16 minus 10, 3, minus 24, 28, minus 11, 26, minus 26, 13. Okay, fine. Now there is another terminology that is called adjoint. Okay, if someone is asking what is adjoint, adjoint is nothing but transpose of cofactor matrix. Okay, so you have to just take the transpose of this. So that will be 16 minus 10, 3 minus 24, 28 minus 11, 26 minus 26 and 13. Is it fine? Tell me.
Yes, sir.
Okay. Okay, now I will write a formula. That formula is quite applicable to find the matrices without any elementary row operation. That formula is A times of adjoint of A equal to what? I know that you know this. Tell me. A times of adjoint of A equal to what? Do you know? Don't know. That is nothing but determinant of A times identity matrix. Okay. Now I will transform this. Suppose I want to get A inverse. Then what will I do? I want to get A inverse from this. Then what will I do? Tell me. From this formula, this is the formula. This is very famous formula and it is very applicable. If I want to get A inverse, then what will I do?
Just shift the A on the other side and determine
Shift.
on the
Okay.
other side.
Is matrix can be shift from this to this?
The
In matrix, this operation is not applicable. This operation is not defined. You cannot something like shift from here to this. You can multiply A inverse. Okay, that operation is applicable. Okay, so what will I do is I will multiply by A inverse both side. Determinant is constant value, right? It won't affect a matrix. Am I right or not? Determinant is nothing but not constant. Determinant is nothing but a scalar. Okay?
yes, sir.
Okay, so what will be this? What will be this? Identity, right? Identity times adjoint of A, that is determinant of A, and A inverse multiply identity, that is nothing but the A inverse. Now A inverse equal to what? Here same, I into adjoint of A, that is nothing but adjoint of A divided by what? Determinant of A. So this is the definition. Here you may ask like, sir, how did you move from here to this? Since it is a scalar, okay, so in scalar you can do, okay, that is applicable. Is it fine or not? So this is the formula of A
Yes.
inverse. Now I will prove this. How I can write A times adjoint of A equal to determinant of A times identity. Can you prove this? Tell me. Can you prove this? Or have you any idea?
Yes, sir. Any method, sir. Take A is a
Huh? What?
2 by 2 meter.
Tell me.
Solve.
Your voice is not clear.
If we take A in the alphabet,
What? Anyone?
if you take A is a 2 by 2 matrix, then we can solve it, na? By solving, we can prove it.
But the thing is, here I am not discussing, I have not said that A should be only 2 by 2 matrix. A can be any kind of matrix. You are just
This is
simplifying the
square
things.
matrix. I am taking 2 by 2 matrix.
Why?
It can be any square matrix.
Is it not applicable to any kind of matrix? Why will I take the only 2 by 2 matrix? If you are proving
I,
for 2 by 2
I
matrix,
am
which means
taking
that is
the
correct
2 by
only for 2 by 2.
for simplification. We can take any square matrix.
Okay, fine. Then here, wait.
Then we are finding the determinant. Then
Okay, wait.
as
Here,
then we can prove.
okay, fine. I can write A as like this. Okay, and at the place of adjoint A, can I write something? What is adjoint of A? What is adjoint of A? Can I write something? Adjoint of A
transpose
is,
of the
yeah, transpose of
transpose cofactor matrix.
cofactor matrix. And cofactor matrix is what? That is C11, C12, C13, C21, C22, C23, C31, C32, C33, right? Just take the transpose. So that will be C11, C12, C13, C21, C22, C23, C31, C32, C33. Okay, fine. Now I will multiply these two matrices. So you can see that this whole row will multiply by this whole column. Then what will be the value? If we multiply this whole row with this column, then what will be the value? Tell me. It is nothing but the whole row multiply by what? A11 C11, A12 C12, A13 C13. That was what? That was what I just talked about. That was nothing but this. Are you getting? That is nothing but,
Yes.
yeah, determinant of A. I will not talk about this. I will talk about this later. This thing. Now you can see the same thing like here also. A11, A12, A13 multiply by what? Here I am talking about this one. So that will be what? A21, A22, 23 and 21, 22 and 23. At the place also what will happen? Here same, right? Determinant of A. Here also determinant of A will come. And here also what? Now it is your task. What are values at this place? If I'm taking, suppose I'm talking about this one. So that star will be nothing but the multiply by this row with this column. So that will be A11 C21 plus A21 C22 plus A13 C23, right? Tell me, this entry is this, right?
Yes.
And if you check this, these values are nothing but 0. Not only this at this place also it is 0, at this place also 0, 0, 0, 0. Now it is your homework. You can check that these values are nothing but zeros. Okay, now take determinant of A outside. That is 1 0 0 0 1 0 0 0 1. That is nothing but what? Determinant of A into identity matrix. Fine. Tell me. Okay. Okay. Suppose if I have system of equation like this, so we already got to know how will I solve the equation. I mean, we already got to know how will I get the inverse. So if I want to get x, then you can take a inverse both side, then that will be a inverse b. So which means that if you are able to get a inverse, then you can easily get the solution. But the thing is, similar thing will happen. You can see that at the formula of a inverse, there is a denominator, and that term is nothing but the determinant of a. If determinant of a is 0, which means that you are not able to get the inverse. So that's why you are not able to get the solution for square matrix. Okay, I'm here pressurizing the term square matrix. Okay, so you are not able to get the solutions for the square matrix if that matrix is what? Singular. Okay, now I'll move to the properties. Is it fine till now?
Sir, can you please explain this again?
This thing,
Yes.
what I'm saying is, if you have the matrix A, I mean if you have the system of linear equations, then easily you can represent it in this form, right? Ax equal to b. Okay,
Yes.
now take the inverse both side. This is what? Identity matrix. So x will be what? A inverse b. That's what I have written. But the thing is, if you want to get x, then you have to get A inverse. And you have to just multiply by b. But the thing is, from the formula of A inverse, you can see that that is nothing but the adjoint of A divided by determinant of A. If the determinant of A is 0, then you cannot get A inverse. And that is applicable for only square matrices. Okay, which means that if matrix has the determinant 0, which means that you are not able to get the solution, and that situation is called what? Inconsistent system of linear equation. That's what I have already talked about. Is it clear now?
Yes, sir.
Yeah. Now I will move to the properties. Properties of determinant. First property, if A is n by n triangular matrix, which means that that will be upper, lower, or identity matrix, then determinant of A will be nothing but the product of diagonal elements. Can you prove this? Can you prove this? Suppose you have upper triangular matrix, right? A11 something. Suppose elements are like this: A22. These elements are non-zero. A33, and these are zeros. Okay, so you can see that I can choose this column because all elements are 0, or you can choose this rows also. Okay, so if you want to determine the determinant of this, then you can write A11, okay, and C11. Fine. And A11 into C11 is what? Just remove this row and this column. That will be minor, not minor. Yeah. So that will be nothing but A22 non-zero term, 0, A33. Similarly, A11 into, again you have this, okay? So A22, or you can just multiply A22, A33, and this non-zero term will be multiplied by 0. So that will be exactly equal to A11, A22, A33. Fine. So that's why determinant of A becomes exactly multiplication of all diagonal elements. Now, property number 2. If A has a row of zeros or a column, then determinant of A will be what?
0.
0. Okay. Now, let A be a square matrix. Then determinant of A exactly equal to determinant of A transpose. Can you prove this? Can you prove this? Or just tell me the idea how we can prove this.
Sir, determinant of A is equal to?
Determinant of A transpose.
Sir, while taking a transpose, the elements only interchange its places. So the value of determinant won't change.
Yeah. The thing is, when you take the transpose, suppose you are taking the transpose, okay? Suppose I'm just taking the find the determinant of A transpose. Then what will happen? Okay. This time I'm not taking the whole row. I'm just taking the whole column. So column will be something like this, right? And this will be C11, C11. But this time that will be not exactly C11. That will be called C-11. Okay, C-12, C-13. Now you can see that C-11 is nothing but row has changed. This row. This row will just flip. At the place of 5, 6, it will become 4, 8, 5, 6. Are you able to get it? So that will be nothing but C-11 will exactly become C11. And A12, that C-12, that will become C12 plus, sometimes it gets dark and sometimes it gets light, plus A13, and C-13 will become C13. That's why that is nothing but the determinant of A. This is one proof. There is another proof. Suppose I want to get determinant of A transpose. I will get the definition. That was what? IJK A transpose 1I, A transpose 2J, A transpose 3K. Now the transpose will be what? Transpose will be nothing but I1. This transpose will be J2. This transpose will be K3. And you can see that it is exactly equal to that's why this is nothing but the determinant of A. This is another proof. Is it fine?
Yes, sir.
Yeah. Now we will move further. Elementary row operation of the determinant. And we will prove each and every property. First property. If I multiply ith row by k times, then determinant of A will be changed to what? If I multiply ith row by k times, or if I multiply ith column by k times, then what will be the change determinant?
The determinant have a multiple of k in the whole value.
Yeah, k times of determinant of A. Can you prove this?
Yes, sir.
How?
If we take any square matrix and we multiply any scalar quantity in one of the row or one of the column, then we have this property that by taking this value common out, the value of the determinant doesn't change.
Yeah. So what he is trying to say is, suppose from the concept of cofactors and minor, I will go, okay, here where it is, yeah, here. Then you can see that if you multiply particular row by k times, then you can see that that will become k times a11, k times a21, k times a31, okay, and c11, c21, c31 will be unchanged, which means that I can take k times of this. That's why that will become k times determinant of A. Is it fine? Tell me. Property number 2. If any two rows or columns are interchanged, then what will happen? What will happen if any two rows or columns are interchanged? Then what will be the effect on the determinant of A?
The sign will change.
Yeah, that will become minus times of determinant of A. And how it happened? The thing is, suppose here epsilon I j k a1i a2j and a3k. If you interchange, then this index will interchange, and that will become jik, and that will be 1i 2j 3k. And you can see that when this index is 1 to 3, it will become 2 1 3, and when this index will be 3 1 2, this will become 1 3 2, and when this index will be 1 2 3 1, this will become 3 2 1. So you can see that when cyclicity lost, -1 come into the picture in each and every term. So that's why determinant of A becomes minor times of determinant of A. You can also see the change by considering that 6 terms to find the determinant. What will happen is, suppose you are taking another row, this row, then what will happen? The rows of the cofactor will flip, and because of that flip, my minus term will come into the picture. So that's why When you interchange rows or column, determinant will change to the minus times of determinant of A. Is it fine?
Yes.
Yeah. Now, if B is the matrix, sorry, B is the multiple, not matrix. Sorry, B is the matrix only. Matrix such that it is the multiple of a row. B is the matrix such that it is the multiple of row of A with the addition of another row of A. Same with the column also. Then determinant of A will be exactly equal to determinant of A. Determinant will not change. Is it correct or not? Tell me. We will prove this. We will prove this using this property. Actually, I used this property earlier. If any two,
Sir, it should be determinant of A is equals to determinant of B.
oh yeah, okay. The next property is if any two rows or column are same, then what? Determinant of A will be 0.
Zero.
Now another property. If A is a square matrix, I will not use it again, because if I am talking about the determinant, this means that it is default square matrix. If A is a matrix with two proportional rows, or column, then what will happen? I am saying, suppose if you have a matrix such that this particular row is directly proportional. Directly proportional is some things like k times of this. Then what will happen? You can directly take the common of this, which means that this two row will be what? Exactly same. Which means that what? Determinant of A will become 0, right?
Yes.
Tell, yeah. Now, property number F. Determinant of k times of A. What will happen? If A is n by n matrix, it will become k raised to the power n times determinant of A. It is clear, right? K times A means what? Each and every element has a multiple of K, which means that in each row you can take K, 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 K. If it is n by n matrix, which means that it has K into K into K, n times. That's why it will become K raised to the power n times determinant of A, right?
Yes.
Yeah. Okay, tell me. Is it correct or not?
Yes.
Blunder. It is not correct. In general. Okay? In general, it is not. But sometimes it happens. When if matrices A and B differs or differ only in a single row or column, then determinant of A plus B will be equal to determinant of A plus determinant of B. For example, suppose A is matrix like this: 175, 203, 141, and matrix B is exactly 175, 203, but this row is different. In this case, if you add this, then the determinant of A plus B will be equal to determinant of A plus determinant of B. Okay, so this is the special case. In this case, you can see that first two rows are exactly same, but the last one are different, or any kind of in any kind of matrix, in only one rows or one column are different. Then if you add this matrix and then you find the determinant, it is exactly will be equal to the determinant of individual matrices. In this case it is okay, but in general it is not okay. Okay, now I will prove this. Where it was? Yeah, so here I will prove this, how it happened. Okay, so what I am saying is, I am making where it went, yeah, here. Yeah, so determinant of B is what? Determinant of A1 A11 plus K times A21 plus A12 plus K times A22 A13 plus K times A23, and it is what? A21 A22 A23 A31 A32 and A32, right? If you do something like, I'm just multiplying this row, I'm just multiplying K times of this row, and I have just added in this row, so that will become determinant of B. Is it correct? That is the operation I have done, what I have understated here, right? Now what will I do is, By using the same property what I have discussed below, then you can see that I can separate A11, A22, A31. Okay, and here A12, A22, A32 plus K times A21, A22, A23, A22, sorry, A21, A22, A23, A31, A32 and A33. So it is the determinant of A, right? And this is what? This is what?
A.
Oh, I think internet has lost. Are you guys here?
Yes.
Yes, yes.
Is everyone here?
Yes.
Yeah. Tell me what is the value of this?
A.
This one is the determinant of A. Sorry, I missed some terms here. Okay. So this is the determinant of A. And this is what?
0.
Hmm?
0.
Yeah. This is exactly 0. That's why determinant of B will become determinant of A. Are you guys following me? This is nothing but the elementary row operation. And what I talked about it when you do some elementary row operation, the value of determinant will be unchanged, because when you do some kind of operation and values separate by using this property, then you will get it, that will be k times of this, and then you can see that these two rows are repeating. So that's why the determinant of this matrix will become 0. That's why the determinant of B exactly equal to determinant of A. Right?
Yes.
Yeah. So in general,
Can I explain?
determinant of A plus B is not equal to determinant of A plus determinant of B. But sometimes it happens when only one row or only one columns are different. Fine? Tell me.
Yes.
Yeah. Tell me, determinant of AB is equal to determinant of A into determinant of B.
Yes.
It is fine. I will give you as a homework. Prove this. How it happens. Because if you prove all this, then I don't have the time. Okay? Now, property number J. What is the determinant of A inverse? What is the determinant of A inverse? It is 1 divided by determinant of A. Take this also as a homework. Prove this. These two are not very difficult. You can easily prove this. Okay. So, Now, which means that, is it visible, this color?
Yes.
Yeah.
Yes.
If A is a n by n matrix, then the following statements are equivalent. What are those? First, A is invertible. Okay. If A is invertible, which means that Ax equal to 0 has what kind of solution?
Unique.
Unique. That is fine. What is that particular name?
Single.
Trivial.
Trivial solution.
Trivial solution. Whatever I am writing is all these statements are equivalent, which means that if you have Ax equal to 0 has only one trivial solution, which means that A is invertible. If A is invertible, which means that Ax equal to 0 has only trivial solution. And also the RREF form of A is what? If A is invertible, then what is the RREF form? What is that?
Identity.
Yeah, identity matrix. All these statements are interchangeable, which means that if you have this condition, then you can prove this also and this also. And also, A can be expressed as a product of elementary matrices. This statement is also equivalent, and also Ax equal to B is consistent for every n by 1 matrix B. Is it correct or not? Is it correct or not? And also determinant of A is not equal to 0. All these statements are equivalent. If you have this condition, then all these are true. If you have this condition, all these are equivalent. Is it fine or not? Tell me. Yes or no?
Yes.
Yeah. Now, take one example. Find determinant of B plus C. I will give 10 seconds and tell me the answer. Your time starts now. What is the value? How? Tell me. 10 seconds is already over.
Zero, sir.
How?
R2 is equals to R1 plus R2. We do operation.
How R2 is okay. Okay, I will change
Then
R1
A
change
plus
to
B plus C will go into common.
yeah. I will change R1 change to R1 plus R2. So that matrix will be what? A plus B plus C. A plus B plus C.
R1 will be equal to R3.
A B
If we take
C
out A
1
plus C.
1 1. Okay.
If,
Now
by
take the
taking out
common of
A
this.
plus B plus.
A plus B plus C, that will be determinant of what? 1 1 1. A B C 1 1 1. You can see that these two rows are same, which means that the value is 0. Fine. Now next question.
Yes, sir.
If A equal to 1 3 4 2, then find the value of lambda such that Ax equal to lambda x has non-trivial solution. What is the answer?
A minus lambda I into x is equals to 0.
What I'm asking? I'm asking find the value of lambda.
5 and minus 2.
Yes. So let's solve this. So what I'm saying is the condition is you have solved this type of question many times, I know that, but here the sentence has changed. So that's why you're getting some difficulties. So the thing is 1 3 4 2. Let's take x as x1 and x2 and lambda take lambda 1 lambda 2 and x1 and x2. Or you can do one thing, just move from here to here. Okay, so ax minus lambda I can write ix. Okay, so a minus lambda I can write x equal to 0. Now what is a minus lambda I? That is nothing but 1 minus lambda 3 4 2 minus lambda, and that is x1 and x2 equal to 0. Now it is asking, I need non-trivial solution, which means that this is a kind of bx equal to 0. This is some kind of matrix where b is this and x is this, and I need bx equal to 0 as a non-trivial solution, which means that this determinant of b should be what? If I need bx equal to 0 such that it will give non-trivial solution, then determinant of b will be what?
0.
0. Okay. Now what is the determinant of b? Simply 1 minus lambda 2 minus lambda minus 3 times 4 equal to 0. This will be a quadratic equation. So that will be 2 minus lambda minus 2 lambda plus lambda square minus 12 equal to 0. Lambda square minus 3 lambda minus 10 equal to 0. So that will be lambda minus 5 lambda plus 2 lambda. So the answer will be lambda equal to 5 and lambda equal to minus 2. So at these lambda, the system of equation will have non-trivial solution. That's why you find what? Characteristic equation. This is called characteristic equation, because during finding the eigenvalue and eigenvector, we don't need trivial solution, because we already know that trivial solution is already included in the non-trivial solution. We always need non-trivial solution. That's why we need the determinant of b equal to 0, and because of that it gives characteristic equation. So at these lambda, this system of equation will have non-trivial solution. Is it fine?
Yes.
Yeah. So from the next lecture we will move towards the eigenvalue, eigenvector, linear dependence, linear independent. Okay. So today's lecture is over.
Hello, sir.
Yeah.
Sir, can you explain first slide, sir? First slide.
First slide. First slide means what? This you are talking about this slide. Slide or OneNote?
Today's first slide.
Slide or OneNote? This is OneNote. Whatever I am writing here, it is
OneNote.
yeah, OneNote. Okay. Where?
Starting, sir. Starting lecture today.
Okay. Actually, I have already shared the YouTube link. Okay, so from where you can get the every week OneNote. Okay, you can get that.